Welcome friends, myself Shoptaporni from BioLive. Hope all of you are doing very well. So today I am going to teach you about a very important topic of species diversity or species diversity index, Shannon Weiner diversity index. Okay, so see here, this is the formula of Shannon Weiner diversity index, also known as Shannon index, okay, which can be represented as capital H or H prime. Okay, so what is the formula? Minus summation of pi ln pi, I equal to 1 and the upper limit is s. Okay, so here I is the ith species in a community and s is the total number of species present in a community. That means s is the species richness and pi is the relative abundance of each species present in a community. That means pi equal to small n by capital N, where small n is the number of total individuals of the species I or any species divided by capital N. Capital N is the total number of all the individuals of all the species present in a given community. Okay, so pi is the proportion of individuals, that means small n, of a particular species I divided by total number of individuals, that is capital N, of all the species found in a community. Okay, ln is the natural logarithm, and I have already told you that s is the species richness or total number of all the species in a community. Okay, now let us take a look on different points, okay, important points of Shannon Weiner diversity indices. What are those? See, this index or this indice takes into account both the species richness, that means the number of species present in a given community, and also the relative abundance. Relative abundance means proportion of any species in a community. That means the number of any species in a community divided by total number of all the individuals of all the species present in that community. That means pi. Here relative abundance is pi. Okay, now the value of capital H for a real community ranges between 1.5 to 3.5. Okay, and greater the value means greater the diversity. Now the value of capital H or H prime, that is the Shannon index, may be range from 0 to H max. H max means ln of s. Okay, that means the maximum diversity. Okay, where s is the species richness. So H max depends on the species richness. Now see, this index is actually based on the concept of uncertainty. What does that mean? See, if a community has very low diversity, that means H value is very less, then we can fairly be certain about the identity of the organism chosen at random. Okay, because if the diversity is very less, then we can easily assume, or we can easily say that which will be the next sample taken from the community. Okay, but if the community has a higher diversity or higher value of H, okay, the highest could be H max, then we have a greater uncertainty about the species that we will choose. Okay, because if the diversity is very high, then we cannot say what will be the next species chosen from the community. Okay, so there will be low certainty but high uncertainty. I think this is now clear to you. Okay, now we will see a problem and we will try to deduct the Shannon index from that problem. Okay, and we will try to compare two communities. So let's take a look. So see here, this is the problem. It is the community A and it is the community B. And in both the community, species richness is same. That means the total number of species present in both the community is same. How many species are present there? 1, 2, 3, 4. And species A, B, C, D are denoted with different signs. Okay. So see here also you can find only those 4 species. So species richness for both the community is same. For both the community it is 4. But see here, in both the community their relative abundance or their number, okay, actually different. See, for community A, species A have 5 individuals. See, this is the species A, the triangle have 5 individuals, okay. Species B have 2 individuals. These are the species B have 2 individuals. Species C also have 2 individuals. These are the 2 individuals of species C, and species D have only 1 individual. This is the species D. Okay. So, total number of individuals in the community is 10, capital N equal to 10. And now we have to find out the relative abundance of each species. Okay. So, how we will find out? Just divide 5 divided by 10, that will be 0.5. 2 divided by 10, that is 0.2. 2 divided by 10, that is 0.2. 1 divided by 10, that is 0.1. Now, with the help of a calculator, you can find out the value of ln pi, okay, natural log of pi. The value is here given, okay, and then multiply the ln pi with the pi, okay, that means multiply minus 0.69 into 0.5 and we can get the value minus 0.345. And similarly we have got these values. And now the main part, take the summation of pi ln pi, okay. As we know, the formula of Shannon Weiner index is H equal to summation of minus summation of pi ln pi. So the summation of pi ln pi is here minus 1.219. So the value of Shannon index will be 1.219. Okay. So this is the Shannon index for community A. Similarly, take a look on the community B. You can easily find that there are also the 4 species A, B, C, D. Okay, so the species richness is same as community A, B, C, D, but their number is different. Okay, see here in the picture, the species A has 3 samples, species B has 2 samples, species C has 3 samples, and species D has 2 individuals. So the number will be 3232. So see here, the number of species A is 3, number of species B is 2, number of species C is 3, and number of species D is 2, and the total number of individuals is n equal to 10. So similarly we have found out the relative abundance of each species, okay, and then the ln pi value, and then multiplying the ln pi with the respective pi value, we have got this. And now the summation of pi ln pi equal to minus 1.364. So the Shannon index for community B is 1.364. So here you can see the HA is 1.219 whereas HB is 1.364. So HB is greater than HA. So see here we have written as HB is greater than HA. So community B has more diversity, okay, than community A. So community B is more diverse. See here, though both the community have same species richness, that is 4, but why community B is more diverse than community A? Because it has more evenness. Okay, see here, these numbers are more even, 3232, than the previous one, 5221. Okay, so community B has more evenness, and we know that the evenness is actually depicted as the gradual slope in the rank abundance curve. Okay, the gradual changes in the relative abundance. Okay, so let's take a look. As HB is greater than HA, so community B is more diverse or have more diversity than community A. Though their species richness is same, that is 4 for both the communities, but it is clearly seen that community B has more evenness or more gradual changes in the relative abundance. Okay, that is like 3232, not like the community A that is 5221. That is why the community B has more diversity than community A. Okay, so this is how we can use the Shannon index to predict the to compare two communities in terms of their diversity. Okay, in my next video I will teach you how to calculate the Shannon index for a hypothetical community. Okay, and in the next and after that I will teach you how to find out the evenness index from the Shannon index, Shannon diversity index. So I hope this video is now clear to you. If you find this video useful, don't forget to hit the like button and share it with your friends, and if you're new to my channel, don't forget to hit the subscribe button. Okay, and thanks for watching and happy learning.